Hey calculus, we are going to learn implicit differentiation. Okay, why do we need implicit differentiation? Because not all functions are solved for y. They don't all say y is equal to. If your equation is solved for y, it has y by itself on one side of the equation, then you can use the product rule, the quotient rule, the chain rule, and so on. But if it's not solved for y, then we need a different way to differentiate, take the derivative. And here's why. If you look at this example down here, okay, in order to use the product rule or the chain rule or the quotient rule or the power rule, you would have to solve this for y. Okay? If you solve that for y, you're going to have a great big mess. All right? You would have to subtract off x squared, so you would have negative x squared plus 25. All right, so you'd have y squared is equal to that. Then you would have to take the square root, so you'd have a great big mess. All right, so we have implicit differentiation that allows us to take the derivative of a function that is not solved for y. And that is why we need implicit differentiation. So before we start, we're just going to look at the first step up here. Okay? We have to learn how to take the derivative of a term using the chain rule. Okay, so we're just going to practice that, because in implicit differentiation, every term that has a y in it, you have to use the chain rule, because y stands for that big messy function. Okay, down here, if I were to solve this thing for y, hey, you'd have a big mess over here. All right, you'd have the square root of a big mess. So every time that we have a term with y in it, you have to use the chain rule, and that's what that stands for. So that's the first thing we're going to practice. Right here, if we take the derivative of y to the first, think of it as y to the first with parentheses around it, because then you can see that the outer function is something to the first, okay, and you can see that the inner function is y. All right, now if we take the chain rule, it would be the derivative of the outer function right here would be 1 times something to the 0. The inner function would be y, and the derivative of the inner function, the derivative of y, we're just going to call it y prime, because we don't know what y is equal to. Okay, so y to the 0 is 1, so 1 times y prime is just y prime. Okay, so the derivative of y to the first, implicitly using the chain rule, is y prime. Okay, so we're going to keep practicing this because there's a really nice pattern. Let's try it again. The derivative of y squared. Think of it with parentheses, because then you can easily see that the outside function is something squared. The inner function is y. So let's take the derivative of the outer. The derivative of the outer is 2 times something to the first. The inner as is y, and the derivative of the inner we call y prime. All right, so we get 2y to the first y prime. All right, now a word to the wise. In implicit differentiation, make sure your 1's and your primes look different, because it gets messy. All right, so the derivative of y to the first is y prime. The derivative of y squared is 2y prime. Let's keep going. Let's do y to the third. So our outer function is something to the third, and my inner function is y. So let's go to work. The derivative of something to the third is 3 times something squared. The inner as is y, and the derivative of the inner we call y prime. So if we simplify it, we get 3y squared y prime. All right, anybody seeing a pattern? Let's do it again. The derivative of y to the fourth, implicitly using the chain rule. The outer function is something to the fourth, and the inner function is y. So the derivative of the outer is 4 times something to the third. The inner as is y, and the derivative of the inner is y prime. So that simplifies to 4y cubed y prime. All right, so now we just follow that pattern. All right, to take the derivative of y to the fifth, implicitly it would be 5y to the fourth y prime. The derivative of y to the sixth, implicitly using the chain rule, would be 6y to the 5th y prime. And one more. I hope you see the pattern. The derivative of y to the 7th, using the chain rule, is 7y to the 6th y prime. Okay? So that's what you have to do for any term that has a y in it. So let's go back up and just read through the steps for implicit differentiation right here. Okay, step 1, you differentiate. Remember, differentiate means take the derivative. All right, a lot of vocabulary in calc. So you take the derivative of both sides of the equation. You take the derivative of every single term in the equation. For every term with a y in it, you have to use the chain rule, and that's what's different. All right, for every term with a y in it, you have to use the chain rule, because y represents that big messy function if you would have solved for y. All right, so the second thing that we're going to do is we're going to get all the terms with y prime in them on the left side of the equation, because that's what we want. We want the derivative. We want y prime is equal to, because we're trying to find the derivative. All right, so let's just go from there. Let's start there. We're going to go to the first example down here. All right, so let me get rid of this, because we're not going to do it that way. We're going to do it implicitly. So we take the derivative of each term. The derivative of x squared, now that is an x, so you just use the power rule. So that is a power rule. So the derivative of that term is 2x. All right, now this term here has a y in it, y squared, so we have to use the chain rule. And we just did that. The derivative of y squared, implicitly using the chain rule, is 2y to the first y prime. All right, and then the derivative of 25, that is just a good old power rule. We know the derivative of any number is 0. So that is the first step. Take the derivative of every term. If the term has a y in it, you must use the chain rule. Okay, the next thing we're going to do is we're going to get the term with y prime in it on the left. All right, so that's your next step. Get all terms with y prime on the left. All right, and then that means all terms without y prime will be on the right. All right, so let's look over here. This term does not have a y prime in it. We move that over to the right side of the equation. So we subtract off 2x. All right, this term has a y prime in it, so it stays on the left. So that's the only thing we need to do. So on the left, we're left with 2y prime. On the right, we're left with negative 2x. Okay, so now we are just going to solve for y prime. Get y prime all by itself on the left. So to get y prime by itself on the left, we need to divide by 2y. And then we need to do it on this side too, good old algebra. So the 2's cancel, the y's cancel. We have y prime on the left. On the right, the 2's cancel, so we're left with negative x over y. And that is the derivative. The derivative of x squared plus y squared is equal to 25 implicitly is negative x over y. There you have it, implicit differentiation. Okay, let's do example number 2. The first step, you take the derivative of every single term. If the term has a y in it, you use the chain rule. All right, so this is just going to be a power rule because it's an x term, so that would be 15x squared. This term has a y in it, so we're going to use the chain rule, and we practice that up above. The derivative of y to the 7th using the chain rule is 7y to the 6th y prime. All right, and then we keep going. The derivative of 2014, and again, that is just a power rule, but we know the derivative of any number is equal to 0. Okay, so now all terms with y prime in it have to be on the left, and all terms without y prime in it have to be on the right. So this has to move over to the right. So we are going to subtract off 15x squared from both sides. All right, this term right here has a y prime in it, so that stays on the left. All right, so on the left now, these cancel. I'm left with negative 7y to the 6th y prime. On the right, I'm left with negative 15x squared. All right, now my last step is I want to get y prime right here all by itself. So I need to get rid of negative 7 and y to the 6th. This is all multiplication in here, so we simply divide by negative 7 y to the 6th, both sides. Negative 7y to the 6th. So those cancel. I have y prime by itself. On the right, simplify it. A negative over a negative, of course, is a positive. So we have 15x squared, 15x squared all over 7y to the 6th. And that's as far as you need to go. Get y prime by itself. All right? Okay, now we're going to try a trickier example. So let's just look at each term and decide what rule we're going to use. Here, that has a term with a y in it, so that is a chain. All right, right here, you have two separate terms being multiplied together. X cubed, the first term, times y to the 5th, the second term. Two separate terms multiplied together. So that is going to be the product rule. All right, so that's where it gets tricky. Remember 1d2 plus 2d1? Okay, now we keep going. This term has just an x in it, so that is just a power rule. And this term 13, that is just a power rule. Okay, so let's go to work. The derivative of y to the 4th using the chain rule is 4y to the 3rd y prime. All right, now the second term. We need to do a product rule. Make sure you put parentheses around the product rule. So, the first function as is x to the 3rd. All right, now we need d2. The derivative of y to the 5th, and that has a y in it, so you have to use the chain rule. That is 5y to the 4th y prime. So there's d2. Now we come back with 2 as is, so we need y to the 5th, and then we need d1. To take the derivative of the first term, that is just a power rule. That is 3x squared. So that is the derivative of this second term using the product rule. 1d2 plus 2d1. All right, so we keep going. The derivative of this term here is just a power rule like we said, so that's 14x to the 6th, and it's equal to 0. The derivative of 13 is 0. All right, so we took the derivative of all four terms. Okay, now, when you have something very messy like this, take a minute and simplify each term. Just clean up each term. Okay, so the first term, there's nothing to clean up. 4y cubed y prime. All right, but these two terms, put them in order. Put the number first, and then the x, and then the y, and then the y prime. So this term here, I'm just going to rewrite it. 5x cubed y to the 4th y prime. Clean it up. Second term, or third term right here, put the 3 first, the x term, and then the y term. So it looks like this. 3x squared y to the 5th. And then bring down these two terms. So take a minute and clean up each term. It's a lot neater, and you can see what you're dealing with. Okay, now we have 4 terms. 1, 2, 3, 4. Every term with a y prime in it stays on the left. Every term without a y prime on it goes to the right. This term has a y prime, it stays on the left. This term has a y prime, it stays on the left. This term does not, so it has to move over. So we're going to subtract off 3x squared y to the 5th minus 3x squared y to the 5th. And then finally this term has to move over to the right. So we're going to add 14x to the 6th. So plus 14x to the 6th. Okay, so on the left, we still have these two terms. We have 4y cubed y prime, and we have this one, 5x to the 3rd y to the 4th y prime. All right, these of course cancel out. On the right side, we have these two terms. We have negative 3x squared y to the 5th, and then we have this one, plus 14x to the 6th. All right, so there we have it. All the terms with y prime in it are on the left. Every term without a y prime in it is on the right. Now, you notice we have two terms that have a y prime in it. We need to get y prime by itself, so we only need one of them. So what we do if there's more than one term with a y prime in it is we factor it out. We factor out y prime. So that means we put it in front and we rewrite that binomial on the left-hand side. When you're factoring out a common factor, you divide. To get this term, we divide the first term by y prime. The y primes cancel, and we're left with 4y cubed. To get this term, we take this second term, and we divide it by y prime. The y primes cancel out, and we're left with 5x cubed y to the fourth. All right, now we just bring this side down as is. Negative 3x squared, y to the fifth, plus 14x to the sixth. Okay, finally, the last step is we need to get y prime by itself. So to get rid of this big mess, we just divide. We divide both sides by 4y cubed plus 5x to the third, y to the fourth. And again, the same thing on this. 4y cubed plus 5x to the third, y to the fourth. Okay, these cancel out, and y prime is equal to this. And there is your big, long, messy derivative. You could factor it, but we're not going to do that. If you can get this far, if you can get y prime by itself, I am thrilled. All right, calculus, that is implicit differentiation. We will do example number 4 later. Bye.